Let's solve another problem on the shear force and bending moment concept. Okay, so the problem goes like this. There is a beam, um, maybe, yeah, so this the beam which is having a uniformly distributed load of W kilonewton per meter. You can think of this as the weight of the beam itself. Yeah, and then it has to be supported on two supports like this, okay, in a way, so which are 18 meters apart. The length of the beam is 30 meters. And but then we have a choice to put this support, okay, anywhere below the beam. So the distance of this left support from the end of the beam is D. Now our aim or our job is to find the location, this D, find the value of this D, so that the bending moment along this axis of the beam means, what should I say, the maximum value of the bending moment should be the minimum. Okay, yeah, that means wherever the bending moment is maximum along the axis of the beam, that should be of the minimum possible value. Okay, yeah, so let's say, now how to solve this. So for that we should try to figure out the shear force and bending moment diagram. Here we are concerned with the bending moment, so I think only the bending moment diagram would do. Okay, now suppose this axis, fine. Yeah, for that first we have to figure out the reaction forces, right? So let me say this is suppose the reaction at R1, and say this is the reaction R2, right? Then what would be that? Say let me figure out this R1. So I'll take a moment about this point. So taking the moment about that point, what would be the value? Say counterclockwise moment, say R1 times 18, right? So this is in the clockwise direction. So the other thing is, yeah, so this full weight, assume that it is acting at the center. Now how much will be the distance, this one? So this full length is 15, right? So this length is 15, out of which 12 minus d has gone. So say 15, say 15 minus 12 minus d, so it will come out to be say 3 plus d. So this distance is 3 plus d. Yeah, so then that is equal to this clockwise, so counterclockwise is 30 meters times w, is the total weight acting at 3 plus d, the distance, because this is the counterclockwise moment. Fine. So from here we can say that R1 is equal to say here 5w by 3 plus d. This is the reaction at the left support. Okay, then so what will be the moment if we consider here, and in this zone, say, let me give some names here, maybe say A, B, C and D. Between A and B what will be the moment, bending moment. So that will be, let me take a free body diagram of a small portion like that. Okay, and then it is the weight, and this distance is x. Okay, suppose this distance is x, and as usual our positive directions are v and m. Okay, so writing the equation that m times m plus, so this is plus, so taking moment about this point, plus w times x is the weight, and this is as if acting at a distance of x over 2, so x over 2, so that should be equal to 0, implies m is equal to negative of w x square over 2. Fine, and in the limit, so m at b minus will be equal to minus of w d square over 2. Fine. Now, so this was in the segment AB. What about segment BC? So that would be, again, if I take a moment, let me do that for completeness. So suppose this is my, so this is my cross section. Fine, and this is the x, and here somewhere maybe the reaction R1, and as usual V here and M here. Now let me write the equation. So M, sorry for that thing, M, and so I'm taking moment about this point, it's counterclockwise, then plus W times X times X over 2. Okay, so it's as if this is acting here, this full weight Wx is acting here. Okay, so that is the moment, minus R1 times distance of x minus t, right? So this distance will be here, I'll write x minus t from here to here. This is equal to 0. So that means your moment will be equal to minus w x square over 2 plus R1 is okay, let me write R1 only, times x minus t. Fine. Now, so if we try to draw these things, we can come and draw it here. So let's say at x is equal to 0, this is 0, and at x is equal to d, this is w d square by 2, and this is the negative with a quadratic, so downward looking parabola. So it will be something like this, right? And the point here is minus w d square over 2. And similarly on this side also it will be something like this. Okay, and in between this will be So that's our roughly the shape of our bending moment diagram. Now we are trying to figure out where this maximum is going to occur. Okay, so this maximum where is going to happen. So that we are trying to figure out. Now how to find that out? We have to do, sorry, take the first moment derivative of dm with respect to dx should be 0. So here that implies wx with a negative, right? From here plus r1 should be 0, implies what's the value of x will be r1 over w. Now how much was r1? R1 is this, over w is nothing but 5 by 3, 3 plus t, right? So this is the location from this end, because we have taken this x from here. So from here, this point is 5 over 3, 3 plus t. Fine. So that's the distance at which maximum will occur, and the maximum value of the moment can be calculated if we just substitute this x here. Fine. So, and that if you calculate, it will come out to be will come out to be 5w over 18. I'm just skipping the algebra. You just have to substitute this x value here. Fine. And r1 also you have to substitute this. Fine. Then you will get this as 45 plus 12t minus t square. So that's the expression for maximum moment. Okay, this is one, and okay, I'll just write the other part here. Another one is mb minus is nothing but negative of w d square over 2. Fine. So these two things we should keep in mind. So see what happens. Here we have to do some arguments. Now let's say what happens. I'm just drawing another picture here. So suppose this is the point. Let's say, okay, I'll draw as if complete symmetric condition. Suppose we start with a complete symmetric form. It means your beam was like that, okay, and this distance was a 6 meter, this side was 6 meters, and this one was 18. So this is a complete symmetric condition. Then our bending moment diagram would be also symmetric, right? And this will be something like this. Right? And in that case, the value, if you calculate, it would come out to be say how much it would be here. This is 6, so this is 36 by 2, so 18, right? Minus 18w would have been the value here. So similarly here minus 18w. But what's the value here? it will be at the center. Fine. Yeah, so here we can put that. So d equal to 6, if you put, it will come out to be around, I have calculated that, and okay, let's see. So this is 36, so 72, so 36, so m max here would be 5w over 18 times 45 plus 36. Okay, so this comes out to be, let me calculate that. Okay, let me check the value I had already calculated for you. That is 22.5. Fine. So see here. So this is 18W and this is 22.5W. So when it is symmetrically placed, this point is at 22.5W and this point is at 18W. So now if I shift it a bit, say the beam I shift to the left, or I say that my the supports I shift to the right, then what happens? Now this will come down. So let me draw it again, another picture. So now I have shifted here like this. Okay, now what will happen is your those bending moment diagram will start from here and it will go lower than minus 18W because more weight has come to this side. So D value has increased from 6 meters, so its value will go down. Similarly, because this has become smaller, so this will be something like this, and this parabola will not be a symmetric one, and it will be something like this. Fine. So it would come down from 22.5 and it will go, this one will go up, or in absolute sense this will be increased, this will be reduced. So we are supposed to find out the position so that either of them should be the minimum, because this cannot go beyond something, this cannot go beyond something. So that can happen only when both of them would be equal. Okay, otherwise the other, if this is more than that, then that's not the minimum which we are looking for. Okay, so the condition for equality will happen when both of them become equal. So then you just have to solve for the case that W d square over 2 is equal to 5W over 18 times 45 plus 12D minus D square. Okay, so if you solve this equation, you will get the position at which position of D where for which uh, the maximum bending moment will attain its minimum value. Okay, so solve for D to get the position where the maximum bending moment will have its minimum value. Okay, so that's what was the problem about. It's a really nice problem. I think we have crossed it. Yeah. So we will, in the next video, we will try to solve one more problem. Till then, enjoy solving problems. Thank you.